Hello everyone, this is Dr. Sankar for SS Academy. Today we are going to discuss about molarity and molality, which is very important topic. In this lecture, we are going to see what is molarity and molality and why it is needed, what is the difference between these two, and where we are going to use molarity, and most importantly, where we should not use molarity. Finally, we will solve a couple of problems so that we can understand this topic very clearly. Molarity and molality essentially gives you the strength of the solution. For example, if you have 10 gram NaCl in 1 liter is less strength than 100 gram of NaCl in 1 liter. Knowing strength is very important for several reasons. For example, stoichiometry. Chemical reactions are more ratio specific. If you don't know the strength of the solution which you are going to use for the reaction, what will happen? You may have leftover or failed reaction. If the strength of the solution is too much, it influences the reaction speed. Since the solute what you are dissolving in the solvent is high, then what will happen? More molecules are there, so that the reaction speed will increase. Also, another example I can tell you, some solutes at very low strength is needed. If that strength is increases, then that will be poisonous. For example, chlorine in the swimming pool. At low strength, it is good. If strength is increases, that means chlorine concentration strength is increases in the swimming pool, then it will become deadly. Molarity is defined as moles per liter. From this equation, we can understand that moles of solute per liter. So volume of solution in liter. So the unit is mole per liter. So we can understand by discussing a simple example. If you use exactly one chemist scoop of sugar, that is 1 mole of sugar, and add enough water so that the final volume is exactly 1 liter, then what is the strength of the solution? So use this formula. So you have one scoop, that is 1 mole, and you added 1 liter water. So 1 liter water. So now it becomes 1 mole per liter. The strength of solution is 1 molar solution. If you add 2 scoop of sugar, that is 2 mole, then it becomes 2 mole. You need to add water only up to 1 liter. So that is what the molarity is about. So now it is become 2 mole per liter. So if you add 2 scoop, 2 mole of solute, then the strength is become 2 molar solution. You can see that if you increase the content of solute in the solution, the strength is increases. So knowing the strength is very critical in the real life example. Uh, Apart from chemical reactions, because in saline drip must be exactly the right molarity to match your body fluids. Contact lens solution needs a precise molarity to clean your lenses without hurting your eyes. Molality is defined as moles per kilogram. So that means moles of the solute divided by mass of the solvent in kg. So here the unit is mole per kilogram. We also discuss in our real life example, just like how we did in molarity, we use uh, one scoop, approximately it is 1 mole of sugar, and we had 1 kilogram of water. Now what will happen to the strength? So we use this formula to calculate it. So amount of sugar is 1 mole, and amount of solvent, now is 1 kilogram, not 1 liter. So now the strength become 1 mole per kilogram. Otherwise, the strength of the solution is 1 mole solution. So you can change, like if we have 2 mole, 2 scoop of sugar in 1 kilogram of water, then this become 2 mole per kilogram or 2 mole solution. Knowing the molality is also very important in certain area. For example, since the temperature of your car changes from freezing cold to the boiling hot when running, we need to use molality to ensure the chemical concentration stays perfectly accurate regardless of the temperature. Now we have understood both molarity and molality. Now you may wonder why we need to define strength in two different ways. Both are molality and molarity gives you the strength of the solution. Why can't we use only one way of defining the strength? Indeed, we need to use two ways like molality and molarity. We will discuss this example so that you can understand why we have to use two ways to define the strength of the solution. Let us imagine you have two container. Uh, One you are having with 1 liter of solvent, another container having 1 kg of solvent. Both containers are completely closed. So now you have 1 mole of solute in each container. Now what is the strength of this container? What is the strength of each container? So this one 1 mole in 1 liter. So therefore this is 1 molar solution. So here also 1 mole in 1 kg, it is 1 molar solution. So now everything is perfect. Now what you are doing now here is, so now you are heating the solution. So now what will happen, let us assume this is the 1 liter mark. So when you heat, what will happen, the solution become expand, it will expand. So after heating, the volume is increases little bit. Let us say 100 ml it increases. Here also it does the same. It increases by 100 ml. Now, what is the true strength of the solution after heating? What is the true strength of the solution? So, for 1 liter, it is 1 mole per 1 molar solution. Now it become 1.1 liter. Now the strength is 1 mole per 1.1 liter. So that is the problem. Whereas here, even though it become 1.1 liter, still the mass is 1 kg. So here it is 1 molar solution. Now you can understand very clearly that when there is a temperature change, we need to use molality. When there is no temperature involved in your process, chemical process, for the solution you can use molarity. Now it may be confusing for you. So now you may understand molality means mole per kg, but in exam time you will forget. So what is for what? So I have a simple technique: molarity liter. You see, molality liter. It is rhyming. Actually, rhyming is not correct. So here, opposite to the rhyming. So molality liter is not correct. That means it is kg. So it is not molality liter. It is molality liter. Not like this. It is opposite to the rhyming. Therefore, it become molality means in kg. So this is how I remember. The molality. Let us solve some problems. So here they ask us to calculate the molarity of the solution containing 5 gram of sodium hydroxide in 450 ml solution. So the formula is given here. So the first what we have to do here is, first we have to find out moles of sodium hydroxide if it is 5 gram and substitute here. Then we need to convert this 450 ml into liter and we have to substitute here because the volume of solution in liter. So here we have in ml for 450 ml. So we have to convert that 450 ml into liter and we have to substitute here. So first we will calculate the mole. So if you haven't watched that mole concept video in our channel, I strongly recommend you to go and watch so that you will understand moles and how to calculate it. So the moles is equal to mass by molar mass. So what is the mass? Mass is 5 gram and molar mass, sodium hydroxide. So sodium and oxygen and hydrogen. Oxygen 16, hydrogen 17. Then if you add the atomic weight of sodium, the molar mass of sodium hydroxide is 40. So what you will get is 0.125 mole. So now we have to calculate uh, uh, liter. So now you have 450 ml. We need to calculate how much liter it is. So we need to use the same technique what we used. I taught you in moles concept video. Here also we have three data. That means we knew that 1000 ml is 1 liter, and now we need to know 450 ml is how many liter. So we have three data. So what is the information we have? Ml and liter. So we have two information. So we know 1000 ml is 1 liter and 450 ml is how many liter, that we don't know. So what we have to do? We have to do the cross multiplication and divided by this remaining third data. So what we have to do is 450 ml into 1 liter divided by 1000 ml. So what we will get if ml cancels, if 1000 goes up, then this will become 450 into 10 to the power of minus 3 liter. So we have to substitute this value. But what we are going to do is we are going to substitute this value because it is easy for us to calculate. Even if you substitute this value also, it will give the correct answer only. But when we solve the problem, you will understand that substituting this will have a very simplified approach. So the moles of solute is 0.125 mole divided by. So this entire value is in given in liter, that you have to understand. That's why we are using this 450 ml per 1 liter. 1 liter we can use liter divided by 1000 ml. So we 1000 ml. So what we are going to do is we bring this 1000 into here. So this will become 0.125 mole into 1000 ml divided by 450 ml liter. Ml cancel. So this is the reason I suggest to use this one instead of this. Now what happened? 0.125 into 1000 mole per 450 liter. So if you multiply 0.125 into 1000, what you will get? 125 mole per 450 liter. So if you divide 125 by 450, you will get 0.277. What is the unit? Mole. If liter comes here, it will become liter inverse. So now the mole fraction of 5 gram of sodium hydroxide in 450 ml is 0.277 mole per liter. Let us solve another problem. Here we have to calculate molality of 2.5 gram of acetic acid in 75 gram of benzene. So here you see you have to calculate molality opposite to the rhyme. So molality means in kg. So that we have to understand very clearly. So first what we have to do, we have to find out the how much mole the 2.5 gram of acetic acid is. Then we have to substitute here, and we have to convert the 75 gram into kilogram, and we have to substitute here. Then we will get that molality of this particular solution. So let us start our calculation. The first step is to find out how many moles of this 2.5 gram of acetic acid is. So the mole is like n equal to mass in grams divided by molar mass gram per mole. So gram cancels. So what is the mass of acetic acid? 2.5 divided by molar mass. So we have acetic acid CH3 COOH. So we have C2O2 H4 total molecular weight. One carbon is 12. So two carbon is 24. One oxygen is 16. Two oxygen is 32. One hydrogen is 1. Four hydrogen is 4. So what is the molar mass? 24, 32, 4. It is 60. So substitute here 60. So what we will get? 2.5 divided by 60, we will get 0.0417 mole. So now we will calculate the convert that 75 gram into 1 kg. So here also we have three data. The first two data is 1000 gram and 1 kg, and 75 gram is how many kg. So we have two set of data. First set is like gram, second set is a kilogram. First data 1000 gram is equal to 1 kilogram. 75 gram we don't know, that is what we have to calculate. Use our technique. So multiply this two and divide by this. So what we will get? 75 gram into 1 kg divided by 1000 gram. So we will get 75 into 10 to the power of minus 3 kilogram. So this is in kilogram. If you multiply divided by this with 1000 gram, this also kilogram. So both are same. That's why we use this symbol. So we can use this one or this one. It doesn't matter. So we use this one similar to our previous molality problem. Why? For our simplicity only. So we use this two data, mole and kilogram data. We will substitute here. So mole is 0.0417 mole divided by 75 gram and 1 kg divided by 1000 gram. So bring 1000 gram here. If it comes here, it is gram inverse. If it comes here, it is gram inverse. If it comes here, then this again become gram. So 0.0417 mole into 10 to the power of 3 gram divided by 75 gram into 1 kg. Gram cancels. Now this becomes like 0.0417 divided by 75 mole per kilogram. So if you divide that, what we will get means uh, 0.556 mole per kilogram. See, we have calculated this molarity also. Thank you for watching this video. Have a nice day.